Good morning. I am going to be going over the semester exam, and there's three different parts, and I'm going to go over part one now. So if we will, go ahead and switch over to this part here. We'll go ahead and get started. So number one says, what is motion? We're going to try to get through these pretty quick. What is motion? Motion is when an object changes its position relative to a starting point. So relative to a starting point. It's when an object changes its position relative to a starting point. Number two says, what's the difference between scalar and vector? Scalar is magnitude only, and a vector is magnitude and direction. And when we look at magnitude, magnitude is just the amount. It's the number, it's the how much. So if we take a look at these down here, this is just a number with no direction. That's just magnitude. Scalar. Just magnitude, no direction. Scalar. So if we go here, we see that there's a direction and a number, an amount. So this is vector. Acceleration is vector. We're going to take a look at distance and displacement here in just a second. Yeah, right here, distance and displacement. So the difference between distance and displacement. Distance is how far in total. It's how far in total that an object has traveled. Displacement, we can just simply state it as how far, or we can put it this way. Where you are from the start. And we can say where an object is from the start. So where you are from the start. How that, and that, when we say where you are from the start, that includes the distance and the direction. Because remember, displacement is a vector. Here's an example of that. If we look, we have someone that's moving 4 meters north and then turning west and traveling for 7 meters. So if we start here, and we go 1, 2, 3, 4, draw a displacement vector. That was 4 meters. And then she turns and goes 7 west. So 1, 2, 3, 4, 5, 6, 7. If we wanted to know the distance traveled is just how far in total. So we simply add those together. So we're going to do 4 meters plus 7 meters, and that's going to give us a total of 11 meters. That's the distance traveled. When it says, what is Abby's displacement? That one is where you are from the start. That includes direction and distance. So where we are from the start, we use a straight line for that, straight line. So we're not going to talk about going 4 north and 7 west. We're just going to say, okay, we started here, we ended up here. What is that distance? So if we look, we have the hypotenuse of a triangle created here. We have a right triangle. So we're trying to solve for that hypotenuse, or C. So when you solve for that, we can say C is equal to square root of A squared plus B squared. Do that, the A could be either 1, we could do 4, and then the other. So we're going to do square root of 4 squared plus 7 squared. And so when we do that, we can plug that in on our calculator and do or get about 8.1 meters. So put that in there, 8.1 meters. And then if we wanted to know the direction, we could simply say this is north, east, south, and west, our direction is northwest, or close enough. Elmo driving a school bus. So if Elmo is driving a school bus, says what is the distance traveled? So distance traveled is going to be distance is equal to velocity divided by distance is equal to velocity times time. So we plug that in. The velocity is 25 meters per second. The time is 30 seconds, and we can multiply those. So 25 times 30 is going to give us 750 meters. 750 meters. Elmo turns and drives the bus 50 meters in 7 seconds. What's the speed? So velocity is distance divided by time. Distance is 50 meters. Time is 7 seconds. And so we can go ahead and take 50 divided by 7, and we get about 7.14 meters per second. School bus 125 meters from school is traveling 30. How long will it take? So for this, we're going to look for time. Time is equal to distance divided by velocity. The distance is 125 meters. The velocity is 30 meters per second. So we're going to do 125 divided by 30 is going to be 4.17 seconds. The bus leaves school from rest and reaches 46 meters per second in 9 seconds. Determine the bus acceleration. Acceleration is final velocity minus initial velocity divided by time. So if the bus leaves school, and we're looking for acceleration, so we can just plug in for that. So the final velocity is 46 meters per second. It leaves school from rest. So that means it started from rest. That's the initial velocity. Initial velocity is going to end up being 0. Okay. So if this ends up being 0, then what we get is the final velocity, which is 46 meters per second, divided by the time of 9 seconds. We don't have to worry about plugging in initial velocity because it's 0. So it's going to be 46 divided by 9 is going to give us 5.11 meters per second squared. All right, 22. Elmo's bus is now traveling 15 meters per second. It accelerates forward. This is our acceleration for 14 seconds. That's time. What's the final velocity? If I take acceleration as final minus initial velocity over time, I can solve for the final velocity. Multiply by time on both sides, and then I have to add initial velocity on both sides. So what I end up with is final velocity is equal to v of I plus a t. So what's your initial velocity? It's traveling at 15 meters per second, and it accelerates. So this is the initial velocity. It's going to be 15 meters per second. That's going to be added to the acceleration, which is 1.5 meters per second squared, times the time of 14 seconds. So we're going to multiply these two first, and then we're going to add 15 to it. So we're going to do 1.5 times 14, and then we're going to add 15 to it. So we end up with 36 meters per second. That is the final velocity. It started at 15, it accelerated for 14 seconds, and it ends up, it accelerates, it gets faster, and it moves to 36 meters per second. Bus starts from rest, it accelerates. How long will it take? So if we're going to do acceleration, is final minus initial over time. Well, we'll multiply by time on both sides, and then we have to divide by acceleration. What we end up with is time is equal to final velocity minus initial velocity over acceleration. This is our equation that we're going to use. So that gives us the final, which is this. Initial is that it starts from rest. So we're going to do 40 minus 0 over the acceleration, which is 3. So really, we're just going to do 40 divided by 3. We get 13 meters per second. Oh, no, 13 seconds because we're looking for time. So 13 seconds. All right, 24. What is the slope equal to in a distance versus time? So if we have a graph, we have distance, we have time, we have a slope. If we were to take a look at this and we did rise over run, the rise is distance, the run is time. So we were given an equation earlier right here. What is distance divided by time? Rise over run ended up being velocity. So the slope of the line is equal to velocity. What is the slope equal to on a velocity time graph? Well, let's do one of those. Velocity time. We're going to do, here's a slope. We're going to do rise over the run. Or in other words, we're going to do velocity divided by time. If we look, velocity divided by time is acceleration. So velocity divided by time is acceleration. Distance time is velocity, velocity time is acceleration. All right. So here we have two graphs. We have a velocity time graph and we have a position or distance time graph. What's happening is we're saying, okay, let's take a look at the velocity time graph, figure out what's happening there, and then try to draw the graph that would be associated with that same exact graph, but only this time on a position time graph or distance time graph. So if we're looking at a velocity time graph, we know that, or we should know, the velocity time graph shows acceleration. And when we look, we see that the slope is up and away, so that gives us a positive slope. So that tells us that we have positive acceleration. For our purposes, we can say that the object is accelerating to the right, or for us, we can just say that it's speeding up. That'll be fine for now, that it's increasing its speed. So in a position time graph, right, or any graph, if you have a straight line shows constant. So this is constant positive velocity. Acceleration means, this positive acceleration means we're speeding up, we're getting faster. So we can't draw a straight line on the position time graph. We have to draw a curved line to show that we're speeding up. A curved line shows that you are changing your velocity, because a position time graph shows velocity. So this is changing velocity and it's increasing its speed. It's changing by becoming faster. If we look here, again, we have acceleration. It's negative because it's sloping downward. So we are slowing down. We can say that the object is slowing down. So we can't have a straight line here because it would show constant velocity, and we don't have constant velocity. We have velocity that is slowing down. So we have something that's curved like this. Here in this velocity time graph, which shows acceleration, we see that acceleration is equal to 0. It's equal to 0 because the slope is 0. Because the slope there represents acceleration, we know that acceleration is going to end up being 0. So this just means that the object is not speeding up and it's not slowing down. That means that it's at a constant speed. Constant velocity. Right? So if it's at a constant velocity, that means that you have a straight line. And we know that it's positive because here is 0 and it's in the positive realm. If it was below 0, which is possible, then that would have been negative. But because it's up here, it's positive velocity, so we know that it's something that's going to look like this. This one was speeding up, and this one was slowing. And then here we see that velocity is on the 0 line, which means it's not moving. So here it's not moving, it's not changing its position, so you're not moving. All right, let's move over here. Which segment has the greatest velocity? When we're looking for velocity, the positive and negative only mean direction. So in other words, if I had something that looked like this, and I had a positive 30 meters per second and a negative 30 meters per second, and I said which one of those had the greatest velocity, or which one was the greatest velocity, well, which one was faster? They would have the same speed. The only difference is that they would be going in opposite directions. So they'd be in opposite directions. So they have the same speed, just going opposite directions. So remember, the positive and negative just refer to the direction, which way they're going. Which segment has the greatest velocity? We're going to look for the one with the greatest slope. Doesn't matter if it's positive, doesn't matter if it's negative. So the one that has the greatest slope is D. It's negative, but that doesn't matter. It's just direction. Which segment has velocity equal to 0? That would be where your slope is 0, because it's a position time graph. So this shows positive velocity, negative velocity. And here, the slope of the line, because slope equals velocity in this one, velocity is going to end up being 0. So the one that shows 0 is B. What is the total distance traveled? Well, the total distance traveled, we would add all of the parts up. So when you go from 10 to 35, you're going 25 meters. Here you didn't move. And then you moved 50, so that's a total of 40. And then you're going to add this segment, and you go from 50 to 0. So it's a total of 40 here and then 50 here. So when I add all of that up, you get a total of 90 meters traveled. Remember, we add all of it up. Direction does not matter in distance. Distance is scalar. Direction does not matter. In displacement, it does matter. It says, what's the displacement of the object at the end of the path? Well, if you started at 10, this is where you started. Where did you end up? You ended up 10 meters away. And what is that? That's negative. The negative tells us direction. So if we ended up 10 meters away, but we ended up in the negative position. So we ended up 10 meters away left of where we started. What is the velocity at segment A? Velocity is distance over time, or rise over run. So for segment A, we started at 10, right, and we went to 35. So it's the distance. To figure out the distance, we have to do 35 minus 10. For the time, we know that it's a segment of 5 seconds. So this ends up being 25 over 5. So that gives us 5 meters per second. For segment C, we're at 35 and we go to 50. So we're going to do distance divided by time. We have to see what that change is. So we're going to do 50 minus 35 over the segment is only 5 seconds. So we end up with 15 over 5, and that gives us 3 meters per second. Velocity at segment D. Velocity is distance divided by time. We ended up at 0, so it's 0 minus, where did we start? 50 over the segment is a 5-second time interval. So 0 minus 50 is minus 50 over 5. I'm going to divide this out, and that's going to give me negative 10 meters per second. What is the acceleration on the velocity time graph? Acceleration is your change in velocity over time. Velocity is the rise, here's the run. So this slope shows acceleration. It's going to give us positive acceleration. If we wanted to figure out what that is, change in velocity would be final minus initial over time. So 20 is the final, initial is 0, so it's 20 minus 0 over the time, it's 5 seconds. 20 over 5, which is going to give us 4 meters per second squared. And that is part 1 for your semester review. I will be going over part 2 and part 3 later.